One thing we found about linear equations is that they have a constant rate of change, right? Everything changes by the same amount. All your y values change by the same amount as x changes. Now, what we have here is something in real life. Here we have, this is something from the New York Times Almanac. They went through and surveyed construction workers and found their average rate of hourly pay in 1980, and then again in 1985, and then in 1990, 1995, 2000, and 2005. And here we have, in 1980, they made about, on average, $9.94 an hour. In 1985, they made $12.32. So that's an increase of about $2.35, something around there, right? Now, so over 5 years, their pay went up by about $2.35. Now, over the next 5-year period, did their pay go up by another $2.35?
No, not really.
No, it didn't, right? It went up by
$1.
like $1.40 around there. And then if you look at the next 5-year period, did that go up by $2.50?
No, it went up about $1.
Or by $1.40?
No.
It went up by like $1.30. And then if you look from this, in this 5-year period, it went up by
$2.40.
Right.
And 39.
Okay. And then here it went up by
$1.98.
about $2 even almost. Okay, so is this going to be a linear equation?
No.
No, because it doesn't have a constant rate of change, right? So this is where we are going to use what's called a scatter plot and a line of best fit. Now, a scatter plot means even though these values don't fall on a line, I'm going to go ahead and graph them. So 1980 and 994. Now, important thing to notice on this graph right here is that it does not start at 0, 0. What does it start at?
1970.
1980.
75.
1975, okay? So the x value, the first x value here is 1975. We don't want to extend it to 0 because that would be to the year 0, and we don't have any data points beyond 1990, so that'd be a whole lot of wasted graph that we wouldn't be doing anything with, right? So, but you do need to make sure and pay attention because our natural inclination when we see this point here is to think that this is x is 0, y is 0, and that's not the case here. Now, one thing they will do sometimes if they have what's called a line break, normally like if this is 5 units long and this is 5 units long and this is 5 units long and so on, then what they'll do sometimes here, since this is 75 but usually that's 0, they'll make a little symbol like this. It didn't show up for some reason.
He's on freeze.
Oh, well that would probably help if I unfroze it, huh? All right.
Good job, Paul.
So,
Smartest one in the class.
that would explain why it's not showing up. All right. So, if we unfreeze it, you can see they'll do like a little, it's like a little, like a V shape kind of above the line and then under the line and then back to it, something like that. It's kind of hard to draw it small, but so a lot of times they'll have that. So if you ever see that on the graph, that's just telling you that, hey, at this point, even though these are 5 units, this is going back to 0. But in this case, this would actually be 1975, 1980, 85, 90, 95, 2000, 2005, 2010. Why didn't you go get it earlier when I told everyone to go get it?
He wasn't paying attention. He wasn't listening.
All right.
I was all like, I thought I had it, but then I didn't.
Okay.
I said I had my agenda.
All right. Yes. All right. Now, to graph these points, first we're going to look at the year 1980, and the value there was 994. Now, where is that on our graph?
It is
Middle Woodton.
Right, it's at over 1980, and it is just a little below 10 Am I going to be able to show 994 exactly? No. This is not going to be exact. Scatter plots are not exact. Lines of best fit are not exact. But somewhere around here is 994, just under 10, right? Then we go on to 1985, so on this line, and we have 1232. Where's that going to go?
Almost in the middle of the 10 and the 12 over 1990.
Okay, right.
No,
Between 10 and 15, halfway between 10 and 15 is
13.
12.5.
12.5. 12.32 is a little less than that, so it's not quite halfway between 10 and 12, or 10 and 15, excuse me. So we're going to have that point. Then we have 1990, our value is 13.77, so not quite 14, so
Over the thing.
it's going to be less than 15 by a little bit. Not so close like this one was. It's still going to be a little ways under.
Less than
So-
15 as well.
So it might be, say, right here. All right. Then we're going to have 1995, and there our value is
15.09.
right, which is almost exactly 15. Again, just a tiny, tiny bit above it. So that point's our point somewhere along here. Then we have 2000. 17.48 goes where?
Almost in the middle.
Right, between
Of
15 and 20 would be 17.5, so 17.48's pretty much dead in the middle of those. And then the last one we have is 2005, where we have, which is pretty darn close to 20, so we have this here. Now, is this a linear equation?
No.
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 Do those points lay on a line? No, do they lay close to a line?
Yes.
Yes. And that line is what we call the line of best fit. Okay? It's not going to be exact, but if we look at this, we can say, hey, generally they kind of lay on this line. Some points are going to be a little above it, some points are going to be a little below it, but if I drew a line, I could draw a line where all the points are fairly close to being on it, right? Now, the line of best fit, the important thing about that is this the line of best fit? No. This point and this point are exactly on the line, but as we can see, this is kind of trend this way, and this one's going to rise much steeper. So this is not, because the rise between, when we were talking about it, we said this is going up by like 2.5, and all the rest were going up by like more like 1.5 or 2. So the rise between these 2 points was the greatest, which is why if I just connect those two, my line's not really going to fit the majority of the data, right? So we need to make a line that, in general, kind of fits those. So how about that line? Does that line look like a pretty good fit to the data? Okay. Now, if you draw a line on your graph, taking notes, copying what I have, is your line going to look exactly like my line? No, why not?
Because we might have graphed it a little different.
It's the line of best fit, so we can fit it.
Right, I mean, you could maybe inch yours up a little bit and want it closer to this point, or you could inch it down a little bit and say, oh no, it's a little above this point, a little above that one, I want it down a little bit. Your line of best fit may be slightly different than mine. Your points could be slightly different than mine. Where I put my 17.5, or 17.48, you might have been like, oh, that was a little high, I think it should be a little lower. So this is not an exact kind of thing, okay? Because look what we're doing here. We are
Best fitting.
predicting. Okay, if we could really predict what was going to happen, then we could tell the future, and I would just predict what the next numbers on the lottery would be, and I would become a millionaire, and I wouldn't have to teach y'all anymore. So obviously, we can't actually predict.
So you don't like this job? Is that what I'm hearing?
Well, versus
We don't like being students.
staying at home with my kids.
So, saying you don't like your family? I might have to.
I said I do like this job, but versus staying home with my kids, I'd rather stay.
But like, kids are annoying. Why do you think?
Where are your kids?
Okay, anyway, moving on.
Racist.
Okay, so
She's Venezuelan.
I'm American. I grew up in Venezuela.
Venezuelan.
All right, now listen, guys. Now, once you have your line of best fit, so when you just graph the points wherever they lay on the graph, we call that a scatter plot. We call it a scatter plot because the points are scattered. They're not on a perfect line. They're just kind of scattered throughout. But in general, if you're doing a line of best fit, they're going to fit somewhat close to a line. Some things closer than others, okay? Because if you were doing this plot and then suddenly there was a bad turn in the economy and for like the next 5 years the salaries didn't go up any, then you're going to end up with a number that's really not going to fit in this data, right? So this, according to the New York Times Almanac, is what it looked like between 1980 and 2010. But if you added 2015 to this, then it wouldn't necessarily follow this trend. This is just what we think based on what we've seen in this trend from 1980 to 2005. Now, let's look at the second part of this. Once we make our scatter plot, step 2, it says use the line of fit to predict the average hourly wage of a construction worker in 2010. So, using the line of best fit, who thinks they can guess, make a good guess, a prediction, if you will, at the salary of a construction worker in 2010? Jake? 20? Okay, why would you guess that?
91.
Okay, guys. James. Okay, Tanner?
$20.74.
Okay, why do you think that?
Because it raises about $1.40 each time. So I was raising a little more than 40 cents.
How much did you say?
$20.74.
Okay. Hannah? Okay. Okay. Where did you come up with your prediction from?
Well, like, some of them come up by like $1 and something cents, and some of them come up by $1.
Okay. The one thing that I'm hearing is none of you is actually using your line of best fit to help you here.
If it kept going, it'd be somewhere around my number.
Okay. Actually, it does keep going. Look at the last data value here. 2010. And 2010, our line is
$21.
right around here. Well, if you think halfway up is 22.5. So I would say this is probably somewhere in the ballpark of like $22. So, guys, now, guys, there is way too much talking going on. You guys are not going to be able to get anything out of the video if you need to watch it, if everyone's having a conversation in the background. Now, the idea behind using a line of best fit to predict is you can extend that line of best fit to get to a point where you can see in 2010. Now, all we know for sure are these points, right? But using our line of best fit, we can predict if things continue to grow in about the same way, the salaries continue to increase about the way they have over the last, 25 years, then in the next 5 years, In the next 5 years, we're at 2010, we look at about $22, just based on where the line would hit at 2010. Now, if I extended that though, and if I said, okay, what about in the year 2035?
No way.
Or yeah, what if I wanted to say, okay, how much do I think a construction worker will make in the year 3035? Well, guys, are you going to want to extend your graph to show the year 3035?
No.
Okay, no, why not? Okay, right. If this shows 25 years or 30 years right here, if I want to show 1,025 years, that's going to be an insanely long graph.
Yeah.
Okay.
You could do you could do like 1,000 and put that as a 1, and then 2,000 put it as a 2, and then 3,000 put it as a 3.
But you still, it's got to actually be the right length, or else this line of best fit isn't going to predict anything, because this line of best fit is showing our rate of change. So if you change what the rate was doing, then it would change your line. Yeah, I mean, if I make this length of time be 100 years instead of 5 years, then this is going to increase a lot more over 100 years, right?
Yes.
So you can't just change the values on the graph.
Is there
Now,
a
guys,
job that keeps like the exact same rate of change like every time?
do what?
Is there like a job that actually keeps the rate of change? Like,
It's very unlikely.
that's what
Okay.
I thought.
Now there are a lot of things, guys. There are a lot of things in life that do have a constant rate of change. Linear equations are something that you'll see a lot. But there are a lot of things that, I mean, this is a real life example. This is taken from an actual source. This is actually what they found the average jobs of construction workers. And it does actually follow a fairly linear pattern, right? So this is scatter plots and lines of best fit is something that is actually used in real life to predict things like, you know, where salaries should be in the next 10 or 15 years. This is something that, like a bank, if you worked at a bank and you were trying to decide whether to loan someone money to purchase a home, you would look at like their employment and how much they're making now, but you would also look at, okay, how much will I expect them to be making 10 years from now? Are they going to be able to continue to make this payment? You know, so you're going to look at things like this if you worked in that kind of position. So again, it's a prediction. It's not 100%, but it gives us at least a good idea of what to expect. Now, again though, I don't want to do 2035 by extending the graph. So tomorrow we're going to look at how to write an equation from our line of best fit and then use that to find future values.